All right, 4.7. This lesson is called Mixed Messages. Limits help us predict y values that are hard to determine, but sometimes the numerator and denominator send mixed messages about the behavior of the function. How can we make sense of this and send a clear message about the function's intended y value? So in number 1, it says for f of x equals x squared. What is happening to the y values as x approaches infinity? Well, as x approaches infinity, y approaches infinity. For the function, and so we could say the limit as x approaches infinity of f of x goes to infinity. For the function ln x, and so you are supposed to remember what that looks like, it says what is happening to the y values as x approaches infinity. Well, the y values slowly are still going to infinity. So we would write that the limit as x approaches infinity of g of x is infinity. So in number 3, which function, f of x or g of x, is growing at a faster rate? Well, I think it's pretty clear. F of x is growing at a faster rate because the slopes of f are getting steeper, whereas the slopes of g are getting flatter. All right, so now we have just figured out that the limit of f of x goes to infinity and the limit of ln x go to infinity. So it says we want to evaluate the limit as x approaches infinity of ln x over x squared. Now, right now we're getting an infinity over infinity. This is called an indeterminate form. However, it doesn't mean that the limit doesn't exist. So this limit as x approaches infinity of ln x over x squared is actually 0. And the reason why is the denominator is growing much faster than the numerator. So the limit approaches 0. Okay, so that's kind of interesting. Kind of interesting what's happening there. All right, number 5. It says evaluate f of 3 and g of 3. Well, I get f of 3, I plug it in, I get 0. G of 3, I get 0. So why does direct substitution not work? Well, this limit is f of 3 over g of 3. I do need to tell you something. Never, ever write equals 0 over 0 or equals infinity over infinity. Those are indeterminate. And so we're going to end up writing the limit of the numerator separately from the limit of the denominator. So f and g are both 0 as x approaches 3, and 0 over 0 is indeterminate. But again, getting infinity over infinity or 0 over 0 doesn't mean you can't determine the limit. So now it says, well, wait a minute. Do you remember earlier, I could actually factor f of x. Then when I cancel, I get 3 plus 5 is 8. So that limit is actually 8. So this is interesting, okay? So I'm heading somewhere with this, okay? So it says now let's look at this limit from a different perspective. How do the values of f of x and g of x at x equals 3 compare? Well, they're the same, and f of 3 equals g of 3 is 0. So, which function, f of g or f of x or g of x, is changing faster? Well, f of x is changing faster. Think about this. F prime of x is 2x plus 2, and f prime of 3 is 8. G prime of x is 1, and g prime of 3 is still 1. So if you compare y values and it's indeterminate, then you're going to compare the growth rates. And the growth rates are derivatives, okay? So now it says, let's evaluate. If I do the derivative of f, that's 2x plus 2, and if I do the derivative of g, it's 1. It's the same as 5c. So when do you think comparing growth rates is a helpful strategy? Well, it's when direct substitution gives an indeterminate form. And here's kind of the big idea. The limit as x approaches a of f of x over g of x. Now this is only when you have the indeterminate form. Then you can compare their growth rates. All right, so what is all of this? Okay, so I kind of went around to develop something, and it's called L'Hôpital's rule. I know it looks like L Hospital, but it's pronounced L'Hôpital's rule. So limits resulting in 0 over 0 or some combination of infinity over infinity are considered indeterminate. So then you consider the ratio of growth rates instead, i.e. their derivatives. All right, so here's L'Hôpital's rule. If the limit as x approaches a of f of x over g of x is indeterminate, you then evaluate the limit as x approaches a of f prime of x over g prime of x. If that result is still indeterminate, you keep repeating. But keep in mind, it has to be an indeterminate form. All right, so in terms of the rubric, you have to do these in a very, very specific way. So if I mentally plug in e to the 0 is 1 minus 1, I get 0 in the top. And if I plug in 0 in the bottom, I get 0. So the way that you have to do this is you have to do your limits separately. Okay, you cannot write equals. So you write them separately. And now I'm going to do the limit as x approaches 0. So e to the 0 is 1 over 1, and that is 1. Okay? So that is, in fact, how you're going to do these. So you do some forward mental thinking, because don't get L'Hopital's rule happy either. So L'Hopital's rule is going to apply. Make this a little smaller here. Then I'm going to take the limit as x approaches negative infinity, 2x plus 10 over 2x. And when I did that, you're going to get, what, negative 14 plus 10 over negative 14. That's negative 4 over negative 14, which is 2/7. Okay, then let's try the third one. So I get the limit as x approaches 0 of my numerator. So that's 0. The limit as x approaches 0 of the denominator. So I can use L'Hopital's rule again. So then this is the limit as x approaches 0, 12x squared minus 12x over negative 10x. Bummer. This is, I'm going to have to, this is the repeated. Oops. So that's 0. The limit as x approaches 0 of the denominator. So L'Hopital's rule applies again. So then this is going to be the limit as x approaches 0 of 24x minus 12 over negative 10. So you get negative 12 over negative 10, which is 6/5. Okay, so a little tedious on that one. All right, then number 4. It says, what if you are given values in a table? Okay, so let's go ahead and do the numerator. So that's going to be 3 times f of 3 minus 6. Well, f of 3 is 2, so that's 0. So that's g of 3 plus 1. That's 0. So L'Hopital's rule applies. So then this is going to be the limit as x approaches 3. Now be careful. I've got a product rule. That's going to be x times f prime of x plus f of x times 1. And then that's all over g prime of x. So 3 times f prime of 3 plus f of 3 over g prime of 3. So I got negative 5/2. All right. Then let's take a look at this one. Now this is going to infinity. So the limit as x approaches infinity of 3x squared minus 7x plus 11. Now, when you think about a polynomial, this is a 3x squared. So it opens up, it's going to shoot to infinity. That leading term is going to overtake the rest of it. So L'Hopital's rule applies. So then I'm going to do the limit as x approaches infinity of 6x minus 7 over 10x. So 6x minus 7, that's going to infinity. and of 10x is going to infinity. So L'Hopital's rule applies again. So then we are going to do 6 over 10, which is 3/5. Okay, so here are the most common. Just remember to never, never, never write equals 0 over 0 or equals infinity over infinity. All right, so let's look at a graph, okay? And it says the graph of f of x is shown below. Find the limit as x approaches 3 of f of x over x squared minus 9. So f of 3 is 0, and the limit as x approaches 3 is also 0. So L'Hopital's rule applies. So then what I'm going to do is I can use L'Hopital's rule, which will be f prime of x over 2x. That's f prime of 3 over 2 times 3. Well, remember, we know how to find the slope. That looks like it's negative 2 over 6, so that is negative 1/3. All right, then we are going to look at one part of a free response question. It says, let f be a function defined by f of x is e to the x times cosine x. Let g be a differentiable function such that g of pi over 2 is 0. The graph of g prime, the derivative of g, is shown below. Find the value of the limit as x approaches pi over 2 of f of x over g of x. So, since we're in L'Hopital's rule, let's go, and so you're coming up here, and that would be e to the pi over 2 times cosine pi over 2, which that I know that looks yucky, but in fact, it's just 0, because cosine of pi over 2. So then this is going to be g of pi over 2. Well, look, they gave me that one. So that's 0. So L'Hopital's rule applies. So then what I'm going to do is this is going to be the limit as x approaches pi over 2 of f prime of x over g prime of x. So this is f prime of pi over 2. So if I come up here, f prime of x would be the first times the derivative of the second plus the second times the derivative of the first. And g prime of pi over 2, so this will be e to the pi over 2 times negative sine pi over 2. Now you know cosine pi over 2 is 0. And then this one, there is a, now this is the graph of the derivative. So most often students are like, oh, there's a corner, but that is, in fact, the graph of the derivative. So that just tells me g prime of pi over 2 is 2. Okay, that wraps it up.